Now. Thank you for inviting me this valuable conference. I'm Jongmin Kim. I'm developer advocate in Lablup, and I came from South Korea. And Lablup is a company making AI infrastructure management software. We call this Backend.AI. And we help everyone to can easily make AI and use it AI. And recently we made a partnership with Vultr. And today I'll tell how Backend.AI unveils the power of virtual cloud. So, okay, please come sit. And these days, many companies and organizations are trying to make AI infrastructures. Today we use lots of AIs such like ChatGPT, and behind these services, there is always a large scale of AI infrastructure. And implementing AI infrastructure requires many challenges, like resource scalings and reduce complexities and increase power efficiencies. And I can tell there is a major two pillars of solving these challenges. And the first pillar is the performance. Performance is usually determined by hardware like NVIDIA GPUs. And to ensure hardware deliver maximum performance, we need to consider data center level factors such like supplying enough powers and cooling systems, hardware not to be burned. And the second pillar is efficiency. Efficiency can be solved by software. Even we have a powerful hardware, it is software which controls them to make maximum performance. Software can monitoring to find the bottlenecks and to prevent system failure. And it can automate the process and schedule workloads, and it also automates the scalings. And it also gives security features like role-based access controls. And there are many needs tasks to meaning these together is much more complex. So this is why Vultr and Backend.AI is collaborated together. Vultr provides cost-effective cloud service and bare metal level performance. And also it adopts latest hardware for NVIDIA Blackwell architecture. And so Vultr can solve the challenge of the performance. And Backend.AI is as a management service, management software, and it does scheduling and orchestrations, the virtual cloud hardware, resources, and it can solve the challenge of the efficiency. So Backend.AI is a platform built for a relentless scale. If you see these lovely pictures explaining about the Backend.AI, and we made the t-shirts, I just wear them here. And as you see, it's our 10 years this year from our company's build. And Backend.AI is using many open source projects, and it is also open source itself. We give easy computing for AI engineers and AI researchers, and it lets a hyperscale computer to squeeze maximum performance. And we can control any size of scale for small JSON or in nano architectures and to cloud data center levels. And with the Backend.AI, you can train and run any kinds of models, and you can also fine-tune using data sets of your own. And you can easily design MLOps pipelines with drag and drop using GUI-based pipeline design tool we provide. And manage everything from single PC level to data center with thousands of nodes, and maximize the utilization of these resources. And we've been developing this platform over 10 years since we started this project. And we are from South Korea. And South Korea, where we're based, we already have over 100 of use cases. And we have use cases of managing 1,500 GPUs with a single cluster. That's the biggest use cases we have. And the number of total GPUs being managed by Backend.AI exceeds 15K. And most of logos are Korean companies and organizations, which is not very familiar with you, but maybe you can recognize Samsung Electronics and LG Electronics probably. And we have also use cases of telco companies like Korea Telecom and automobile companies who makes trains their AI to auto drive their vehicles. And also like financial use cases, Bank of Korea, and also public institutions and military services are our customers. And we are NVIDIA DGX Ready software and officially recognized for NVIDIA management software usable by NVIDIA DGX system. And worldwide, only 18 companies got these qualifications, and we are only one from Asia Pacific. And we can confidently say that we are a variety of hardware to support this more than any of other infrastructure solutions currently. Because we support most NVIDIA GPU chips that are widely used in AI development these days. But we also support AMD and Intel, Graph-Core, and Tenstorrent, and Rebellions, and also we support the GPU direct storages. Like companies like Pure Storage, Dell PowerScale, Weka, and Vast Data, and like NetApp. And we collaborate with many cloud partners, including Vultr here, and some Korean cloud companies like KT Cloud, NHN Cloud, and the Naver Cloud. While most of these logos are currently Korean local companies, we expect to continue expanding global logos with Vultr. Let me explain a little bit more about the Backend.AI features using our own project map. Because of our solution is called Backend.AI, it doesn't mean we build only backend system. We also have a front end and various UX and UIs. And first, the infrastructure layer at the underneath. Backend.AI core is installed on top of data center like Vultr to manage resources like GPU, network, and storages. And this includes tools like workload management and monitoring, and especially Sokovan, which we handles orchestrations and scheduling. When you see the word of orchestration, maybe you can probably think of the Kubernetes. In fact, many infrastructure management softwares are designed in top of the Kubernetes. But instead of using Kubernetes, we built our own orchestrator named Sokovan, and from the scratch, and there are several reasons we did that. First, Kubernetes is a very well-designed tool, but it's originally created to orchestrate the web service and microservice architecture. However, when it encounters AI and the HPC level workload, it becomes a difficulty to guarantee performance and security isolation between different tenants and instances. So Backend.AI directly handles kernel level resources like CUDA drivers, and so because of this functionality, we decided to design the orchestrator from the scratch by our own. And on top of this infrastructure, there are various UX and UI layers, and we have tools like a Fast Track, which allows you to create two MLOps pipelines with drag and drops. And we have a Pali, which allows you to install and run inference service for AI models deployed from NVIDIA NIM or Hugging Face with just a few clicks. And at the top, there are service level applications like automatic fine-tuning and chatbots. We installed the Backend.AI on Vultr's latest hardware, NVIDIA B200 instances, and conducted a benchmark test. And I heard that Vultr Cloud is actually one of the instances where NVIDIA B200 was applied very early. Lablup has been using H100 system before, and we conducted a comparison test with Vultr's B200 and discovered meaningful results with H100 currently we used. With the H100 as the baseline 1.0, when we tested the throughput, with the Llama and the Qwen models, we actually saw B200 performance of the more than 5 times, up to 6.3 times. And also we tested the response time. We confirmed that while H100's time to first token was increasing rapidly when token size reaches beyond the 16K. But for B200, it shows us very stable numbers, so even it reaches beyond the 16K and even 32K. Response time is a very important metric because it's directly related to user-friendly experience and for implementing actually service level. Backend.AI uses container technology, and we apply our patented fractional GPU virtualization, and we hold this patent in Korea and the US and in Japan. This technology actually slices NVIDIA GPU CUDA core levels and memories to make efficiency process smaller workloads at the same time. NVIDIA also provides several GPU virtualization technologies themselves, but our Backend.AI has advantages. We're supporting more CUDA versions, and we have a complete sandbox-style isolation for the security. And we provide compatibility for these features, not only AI GPUs like H100, but also we provide this function with gaming GPUs like RTX 4090. And thanks to Vultr, we proved that it works perfectly on Blackwell-based architecture too. Sokovan serves not only an orchestrator, but also a scheduler. At the cluster level, it handles job scheduling and assigns containers and sessions to each node according to policies. And if you are familiar with the HPC world, maybe you heard of the Slurm, a job scheduler of HPC, and Sokovan is something that Kubernetes plus the Slurm. And for the node level, it handles a hardware technology where scheduling devices, assignment for each container, and connections like GPU direct storage and high-speed connections. In this way, Backend.AI can reach maximum performance for AI infrastructure. Also in NUMA AR resources mapping, we also arrange resources in close distance of actual workloads, and it can give you the best hardware combinations. Not only for the GPUs, but we also support the storage virtualizations. We implement and apply dedicated storage proxy for each container. This allows the integrates the use of GPU direct storage features that the different storage vendors provide separately on their way. And to making AI models has not only training, but actually it requires multiple stages like collecting data and pre-process it, and training models and deploy it to the service and many other things. We provide MLOps platform named Fast Track that allows you to draw and implement pipelines through drag and drop without the coding. And we have service Pali, the most recent released application in our Backend.AI ecosystem. Pali stands for Performant AI Launcher for Inference, and Pali means in Korean like hurry up, Pali Pali. And you can register open models from Hugging Face or upload your own customized and trained model to Pali Model Store. And whenever you need them, you just, with a few clicks, you can install these models direct to your own instance. And Pali will immediately install your selected model to your instance, and with execution environment like VLLM. And it creates an endpoint itself and all needed services for end users. And with a simple chatbot, you can test it too. We are at South Korea, but there are some global conferences important for us, and we attend every year. And one of the most important conferences is NVIDIA GTC. GTC is an annual conference hosted by NVIDIA and held in Silicon Valley. And this year, we also attended as a sponsor and gave a talk at GTC with the title of Universal NIM Acceleration with the GPU Sharing Containers. You can visit the GTC webpage and search for our talk if you are interested. There is a session ID over there. And NIM is a stand for NVIDIA Inference Microservice, which is an AI deployment solution directly operated by NVIDIA. And Backend.AI Bali supports running NIM images as well too. And since our first day, Lablup is executing the mission that make AI accessible, so that everyone, including AI engineers, developers, and researchers, can easily create and utilize an AI. And recently, we also working to solve AI scaling challenges while large language models keeping scaling up. And we also solving the challenges of the small scales AI that are embedded directly in the devices or language models included inside the operating system or inside the set-top box like automobiles and vehicles. And that's all for today, my talk. And thank you, Vultr team, again, to be inviting me in this various event. And please enjoy your conference. And we have some paperwork that we made a benchmarking test over there with the Vultr. And please have a good day for today. Thank you.